Welcome to section 0.6 day 1, trig functions. Today's objective is to describe the characteristics of trigonometric functions. So for sinusoid functions, we have this f of x equals capital A sine brackets capital B in parentheses x minus c, close off your parentheses and brackets, plus d. So the A stands for your amplitude, your vertical stretch. It also, if you put a negative in there, it'll reflect it around the x-axis. The B is your period. How often does the sinusoid repeat? It also gives you your horizontal stretch, and it tells you if it's a negative, it's going to reflect it around the y-axis. The C is your horizontal shift, which way you're going left and right on the x-axis, and the D at the end is your vertical shift. How much does it move up or down on your graph? We have the periods of trig functions, and you should hopefully already know this, that sine and cosine repeat every 2 pi. So basically the full distance around a circle, they'll repeat. The tangent and cotangent have a period of pi. It's important to know these, so if you don't know them already, please remember them. Now we are going to find the period and amplitude of these functions. And we have y equals 3 cosine 3x. From the last slide, we had f of x equals a. We'll use the sine one that we had before. We had b x minus c plus d. With the functions we have here, they are not as complicated as the formula that was given on the previous slide or what I just wrote on the top of this slide. But it does help us, if we remember this, what's going on with each of these. So the first thing we want to find is the amplitude. And the amplitude is just the coefficient in front of cosine. It's our A, which is just 3. Then our period, we can do some things to find out what our period is. So our period is 2 pi for cosine. We have in this one a 3. So we have 2 pi over some p equals 3. So our period is going to be 2 pi over 3. So that is my amplitude, and that is my period. Looking at the next one, we have y equals negative 2 sine of 4x. Our amplitude, I'm just going to use my big A for amplitude here, is negative 2. Our period, how often does this thing repeat? We're going to do the same method. We're going to say our sine function is usually 2 pi long, so 2 pi over p, in this case, is 4. And when you solve this for p, you get p is by halves. And that is my period. For the next one, you can already see that the amplitude, in this case, is 1.5, because that's our leading coefficient. And then for the period, the tangent function has a period of pi. So we're going to have pi over p has to equal 2. So the period is pi over 2. And the last one we have y equals negative 5 cosine pi x. Our amplitude is, again, the coefficient of negative 5. The period on this one, when we do this, again, cosine has a period of 2 pi. So 2 pi over p equals pi. When we solve for p, we find our period is 2. So that is finding the amplitude and period of each of these functions. They're not always as easy to do, as you'll see in the next slides as we go forward. It's good to understand when you're looking at these cosine, sine, and tangent functions what the graph looks like going forward. This will help you when we start getting into doing derivatives and doing integration later on this year. On this slide, we have a more complicated function, and it says for this function, determine the period, the domain, the range, and then sketch a graph. Again, from our previous slide, we had f of x equals a, and our sine function or cosine function would fit next. And we had b x minus c plus d. We want to determine the period, the domain, the range, and sketch a graph. You notice in this one, we have 2x plus pi altogether. To make it in the same form that's above, where we have b, and then in parentheses x minus c, we must divide out a 2. So we're going to rewrite this, and we get y equals 3 sine, and then 2 x plus pi halves minus 1. So we'll look at the first thing. It says to find the period. So b is what's going to give us our period. Our sine function has a period of 2 pi. So for our period, we have 2 pi over p equals 2. And so our period is pi. It says determine the domain and the range. Well, in this function, we have a sine function. We have an amplitude of 3. We have a vertical shift here of -1. So we know that we are going to have a center line of our function that goes through -1. And it's going to go up and down 3, so our tops of our graph will be at 2 positive on the y and -4. Our domain will be -infinity to infinity. And then our range, because of our vertical shift and our amplitude, goes from -4 inclusive to +2 inclusive. There's our domain and range. Now it says to sketch the graph. So we have our center line. We know it's going to top out at +2. We know it's going to go down to -4. And we have a period of pi. So this thing's going to repeat every pi. Our amplitude is 3, so we know the top of our function will go to +2. We know the bottom of our function will go to -4. And then when you start looking at how this thing is shifted, we're shifting over pi halves. I'm going to mark our graphs at each of our pi, -pi, -2 pi. On this side we have pi, and we have +2 pi. We're going to shift this thing horizontally to the left by ½ pi. So at ½ pi, we will be at -1. -pi4s will go to 2, which is right here. At 0, we will be down again at -1. And every pi4s, we're going to do this. So we have a curve that looks something like this. So there is a sketch of our graph. Again, this is something that's important to be able to do when we get later on in the year when we're looking at integration and we're looking at differentiation to understand how these sine, cosine, tangent, cotangent functions operate. The next thing we're going to look at is arc length. Your arc length, denoted with S, is your radius times your angle measured in radians. So remember, theta is in radians. If theta is given in degrees, you should know how to change it to radians. So if you're given something in degrees, you will change your formula to be something where you have your theta in degrees, and you're going to multiply by pi over 180. This will be used to change from degrees to radians, pi over 180. On today's assignment, you will be having to change stuff from degrees into radians, and you have to take stuff from radians and back into degrees, and you should be able to do that. That is all for section 0.6 day 1. Working with sinusoids and analyzing their graphs. Thank you for watching and have a nice day.